Hello. Today I will be teaching you how to draw Lewis structures. Alright, we're going to go into it. Step 1. We're going to count how many valence electrons there are. So we're going to do H2O. Now, hydrogen has one valence electron. However, there are two molecules. So we're going to multiply it by 2. Next, oxygen has a total of 6 valence electrons. Now we're going to add them all together. 2 times 1 plus 6 is equal to 8. Alright, now we're going to try another molecule. We're going to do CO3 minus 2. This is an ion. So now this is a little special. So first off, carbon has 4 valence electrons. Oxygen has a total of 6 valence electrons. But since there's 3 molecules, we're going to multiply it by 3. Now since this is an ion, we need to add 2 electrons since it's minus 2. Now we're going to add them all up. 4 plus 6 times 3 plus 2, that's all going to equal up to 24. And also later, we're going to come back to this molecule. So now we're going to talk about the central atom in a molecule. This only occurs for a molecule that has 3 or more atoms. So we're looking at PCl3. Now, the central atom will be the one that has the least amount of electronegativity. As you can see in the periodic table, phosphorus, P, has lower electronegativity than chlorine, Cl. That means that P will be the central atom in this molecule. Next, we're going to move on to another molecule, CO3 minus. So now, looking at the electronegativity again at the periodic table, carbon has a lower electronegativity than oxygen. This means that carbon will be the central atom in this molecule. Next, now we're going to go to H2O. Now, if you're going to look at the periodic table, you will expect hydrogen to have the lower electronegativity and be the central atom, and since oxygen has a higher electronegativity. However, oxygen will be the central atom, and here's why. So, the reason is this. Hydrogen is one of the exceptions. It is special. It only has one bond, and it's always on the outside of the central atom. So this means it is a terminal atom. Now we're going to move on to boron. So boron, when it's a central atom, it will actually have less than the octet rule. This means it will have 3 bonds, which is 6 electrons. Now, another exception is when an atom has a D shell. So, this means that it can have more than the octet rule, which is 8 electrons. But it cannot have more than 12 electrons. So now, we're going to go into step 3. Actually drawing the Lewis structure. So let's start off with H2O. Now we already determined that oxygen will be the central atom, so we're going to draw that in the middle. Next, you want to just draw single bonds to the other 2 atoms, which is hydrogen. Now we determined that the amount of valence electrons it has is 8. So since hydrogen only bonds with a 1 bond, we cannot add any more electrons to it. So we're going to add the rest of the electrons to the central atom, which is oxygen. And then we're going to have a total of 8 valence electrons. Now, we're going to do another molecule, BF3. So we're going to first off count how many valence electrons this molecule has. So boron has a total of 3 valence electrons, and there's only one. So then we're going to add fluorine. Fluorine has 7 valence electrons, and there's 3 of them. So 3 times 1 is 3, plus 7 times 3 is 21. So we have a total of 24 valence electrons in this molecule. Next, we know that boron has lower electronegativity, so it will be the central atom. So also remember the exception is that boron will bond with less than the octet rule. So it will not have a total of 8, but it will have a total of 6 electrons. So now we're going to bond fluorine to each one with a single bond. Boron is already complete because it has 6. But however, fluorine does not complete its octet. So boron's good, but now we need to add the electrons to fluorine. So fluorine has 2, 4, 6, 8. We're going to add it to another fluorine, 6 more electrons, and then to the last one as well. Now we're going to count them all up. 8, 16, 24. And that completes the amount of valence electrons we have. So it's all good. Now we're going to do another molecule. We're going to do xenon F4. Now xenon has a total of 8 valence electrons. And there's only one of them, so we're not going to multiply by anything. And then fluorine has 7 valence electrons, and there's 4 of them, so we're going to multiply by 4. So 7 times 4 is 28, plus 8 equals 236. So then xenon has a lower electronegativity than fluorine, so it will be the central atom. Next, we're going to do a single bond to each of the fluorine atoms. Now, when you count it all up, we have 2, 4, 6, 8. That's not 36. So now we need to add some electrons. So we're going to complete the octet for fluorine on each of one of them. So we're going to add 6 to each. Now, when we count it all up, 8, 16, 24, 32. We're still missing 4 valence electrons. So now we're going to add that to the central atom. Now this is part of the exception. Xenon has a D shell. This means that it can have more than 8 valence electrons, so it can surpass the octet rule. Now we're going to talk about resonance. Now we're going back to the molecule that we talked about earlier, CO3 - 2. Now this is an ion for sure. So first we're going to count out the valence electrons. Carbon has 4, oxygen has 6, times it by 3 because it's 3 molecules, plus 2 since it's an ion, and we're going to get a total of 24. Now, carbon has the lower electronegativity, so it will be the central atom. Next, we're going to do single bonds to each of the oxygens. Now, since the carbon does not complete its octet yet, we're going to add another bond. And we're going to bond this with the oxygen. Now, it completes its octet, 2, 4, 6, 8. Now, however, that doesn't complete the total amount of valence electrons we have. And also, the oxygens do not complete their octet. So, we're going to add the electrons to the rest of the oxygens. And just to tell you is that the reason why we're not adding the electrons to carbon is because it does not have a D shell orbital. So it cannot have more than 8 electrons. So now we're going to count them all up. 8, 16, 24. That means that we're all good. And this is one set. So now what is resonance? And how does this relate? Resonance means that when a molecule cannot be represented by just one structure. So I'm just going to draw what we just drew at first, the Lewis structure of CO3 - 2. But we're just going to ask the question, how does this relate? So I'm going to draw CO3 minus 2 again. But you notice, I'm keeping the position of the atoms in the same place. However, if you notice, there's a double bond between the oxygen on the left in the first structure, but this time I put a double bond with the oxygen on the right. And now, this means is that CO3 minus 2 has a different structure, and this is also valid because it completes the octet of each atom and also has a total of 24 valence electrons. And now, if you notice, I'm doing a double bond with the oxygen on the bottom. This is another valid structure. So this means that CO3 minus 2 has 3 Lewis structures. And this is resonance. Thank you for watching and listening to how to draw a Lewis structure. If you need any more help, ask your teacher. Thank you.